Unit 6 review, two-way tables and scatter plots. Number 1, Casey goes to her local ice cream hangout. While she is there, she takes a survey of 84 people of what type of ice cream the people like. She collects the following data. 45 people like mint chip only. 17 people like both mint chip and cookie dough. 34 people in total like cookie dough. Okay, so the first piece of information I got was this 84 total people. That would go right here because 84 is the grand total of the whole survey. That's all the people that she talked to that day. All right, now let's go step by step. 45 people like mint chip only. Okay, so I'm looking at my table here, and mint chip, they like mint chip, that's here, and they like mint chip only. So this side says likes cookie dough and does not like cookie dough. So mint chip only, I believe, would go right here because that means they like mint chip, but they don't like cookie dough. So they only like mint chip. Let's look at the 17. 17 people like both mint chip and cookie dough. Okay, so now that's here. They like mint chip and they like cookie dough. So the 17, I believe, goes here. And our last piece of data, 34 people in total like cookie dough. So 34 people in total like cookie dough. So here's our row of likes cookie dough, and here's our total. So 34 in total. Okay, so look at those spots. Now from there, we should be able to complete the rest of the table. So I like to go where I have the most information. So right here, 17 and 45. So to get this total, right here, I'm just going to add those together. So that's going to be 1262. Okay, now I'm going to go maybe right over here. So I have to figure out 34 plus what would get me that 84. So I'm just going to work backwards, the inverse of that, and subtract those two. And that is 50, because 34 plus 50 gives me that 84. Okay, now I'm going to go horizontally. I'm going to go across the rows. So looking across, right here, I have 17 plus what would give me that 34. So I can do another subtraction problem. I can do 34 minus 17, which is going to be 17. Okay, so that would go, let me just clean up my table here a little bit. That's going to go right here, 17. Because 17 plus 17 would give us 34. Now I can see that I have 50 as a total here, so 45 plus 5 would give me that 50. And then finally I can go down the table, and 17 plus 5 gives me 22. I should also cross-check everything. So I want to make sure that everything adds up horizontally and vertically. So I'm just going to double check right here. 62 and 22, that's 84. And 45 plus 5 is 50. 17 and 17 is 34. So horizontally everything checks. And then vertically, we've already done that part. Okay, so your table should have those values in there. And now for the trickier part. Now is the relative frequency. Okay, so those are our, we can set them up as fractions. We divide them to decimals and make them into percents. Okay, but you have to be a very, very careful reader here. Okay, so let me move this up a little bit. Okay, so what is the relative frequency of people surveyed that like mint chocolate chip ice cream? So we want the relative frequency of the people surveyed that like mint chocolate chip ice cream. So the of gives us our total. Okay, so when you see the of, that's going to be our total. So that's going to be the bottom of our denominator. So it's of the people surveyed, and 84 in all were surveyed. So that's our total. So that of is our 84. Now, they like mint chocolate chip ice cream. So I'm going to go look at the table, and I'm going to do, of all the people surveyed, how many like mint chocolate chip ice cream? So of all the people surveyed, 62 like mint chocolate chip ice cream. So we had to do that part out of that total. Now I'm going to go ahead and grab my calculator and divide those. So 62 divided by 84. Okay, so I get, when I do 62 divided by 84, I get 0.73809, and it keeps going. Okay, so now I'm going to change that to a percent. I can do one of two things. I can either just move the decimal 2 positions, or I can, in the calculator while this is in here, I can times it by 100. Okay, so I'm just going to move 2 positions, and then I do see that it tells me in the directions to round to the nearest degree here. So round to, so I don't have to, wait, I want to erase that. I made a big mess here. Okay, so you can see that. Round to the nearest degree. Okay, so that means it's just going to be, let's see, 73.8. So this 8 would make that round up. So our answer will be 74%. So 74% of the people surveyed like mint chocolate chip ice cream. That answer is reasonable because 62 people out of the 84 would be a pretty high percentage. All right, next one. What is the relative frequency of people who like cookie dough ice cream that don't like mint chocolate chip? Okay, so again, the of is our total, so that's going to be our denominator. So the relative frequency of people who like cookie dough ice cream. So now I'm just focused on the people who like cookie dough ice cream. So that total right there. So 34 is the total of the people who like cookie dough ice cream. Now, I'm only focused on that horizontal part of the graph. I want to know the ones who don't like mint chocolate chip. So that would be this value right here. 17 of them don't like mint chocolate chip. Okay, and then we would grab our calculator and do 17 divided by 34, which is 0.5. And then now I can either move that decimal 2 positions, move it 2 places, or I can times this by 100. Okay, so if I just move 2 places, that would be 50%, which makes sense, right? Because half of the people, 50% of the people, it was half and half up here, was split, 17 and 17. So 50% of the 34 don't like mint chocolate ice cream. All right, so careful reader there, and the of is your total. Question 2. Based on the table in question 1, find the relative frequency by column. Round your answer to the nearest degree, the whole degree. Okay, so I'm going to focus on this column, which is likes mint chocolate chip. So the total is going to be out of 62 for the first column. Okay, so we said 17 out of the 62 like mint chocolate chip. Okay, again, because I'm going by the columns. See how my 100% is at the bottom of the column. And then 45 out of the 62 like mint chocolate chip. And then now while I'm at it, I'm going to do the next column, does not like mint chocolate chip. Okay, so that was 17 out of 22. and it was 5 out of 22. Do you see where I got those numbers? Again, I'm focused by the column. And then now I'm just going to grab my calculator and divide those and change them into percents and round to the whole degree, the whole number. Okay, so 17 divided by 62, and I get 0.274. And now I'm either going to move the decimal 2 places, or you can multiply by 100. And I'm rounding to the whole degree. So that's going to be 27%. That 4 makes it stay at 27%. Okay, so 27%. Okay, 45 out of 62. And that I'm going to divide that. And I get 0.725, etc. Okay, now I'm going to go, either your choice. You can move the decimal 2 place, or you can multiply that by 100. You'll get the same thing. And this one will round up because I'm rounding to the nearest whole degree. So this rounds to 73%. And now I should just double check that 27% plus 73% should equal 100%, which it does. Now I'm going to go to the next column and do 17 divided by 22. Remember, I used 22 for the total for does not like chocolate mint or chocolate chip. When I divide that, I get 0.772. Okay, again, I change that decimal into a percent by either moving the decimal 2 places or multiplying by 100. And that's going to leave me with 77%. And now 5 divided by 22. So put that in my calculator. 227, etc. Again, either move the decimal 2 places or multiply by 100. And this one, because this number is a 7, this will round up to 23%. And then I got to make sure that if I add those two values together, that those total 100, which they do. Now, another thing I could have done is once I got this 77%, I could have just said, oh, well, 100 minus 77 is 23. But I like to make sure that it all matches and it all works out correctly. Okay, so relative frequency by column means you just, focus vertically on that group of numbers and setting them up. That's the hardest part. State the correlation for each of the following statements. And you'll say it's either positive, negative, or there's no correlation. If both things seem to increase, we would say positive. If one increases while the other decreases, we would say negative. And if they don't seem like they're related at all, we say no correlation. The age of its car and its value. Okay, so my car, I get it brand new. It's expensive when it's brand new. But then over time, as my car gets older, the value of the car would decrease. So I would say that is a negative correlation. Okay, unless, of course, I keep it in pristine condition, it's some sort of collectible, but in general, speaking about cars, as soon as you drive it off the lot, it goes down in value. Okay, the number of students and the number of teachers. Well, the more students we have in our building, the more teachers we're going to need. So as the students increase, the number of teachers would increase. So that would be a positive correlation. All right, the next one. High temperatures in Florida and the number of water bottles sold. Well, when it gets hot out, we want more and more water. So if the temperature keeps increasing, then those water bottle sales would increase, I would think. So that would be positive. Okay, minutes on a treadmill. Minutes on a treadmill and the calories burnt. Okay, so I'm on a treadmill. The more minutes I'm on there, I increase the minutes. So I would think that the calories would also increase. I would keep burning more calories. That'd be positive then. The weight of a dumbbell and the number of reps. Okay, so it's getting heavier. If my dumbbell weight increases, it's going to be harder for me to lift. So I would probably be doing fewer reps. So that would be negative. And then the last one, the height of a person and the number of letters in their name. I mean, you could have a 6-foot tall person and their name could be like Al with 2 letters, but their name could also be like James. So I don't think that this would relate at all how tall you are and how many letters are in your name. So this would be no correlation. Okay, now moving on to a scatter plot. The prices and sizes of 20 different diamonds are shown on the scatter plot. So each one of these is a different diamond. Okay, so let's take a look. So the prices, here's the weights in carats and the price in dollars. So you can see that the more, in general, the more it weighs or the bigger the diamond is, it looks like, the more expensive the cost would go up, the price would go up. Okay, so we're going to try to draw a line that we think is a good fit for the data. And remember, when we're drawing a line of best fit, we want to split the data and kind of have an equal amount of points above and below as best as we can. Now, it looks like we're starting around the 4,000 mark. So I might have to do this a couple of times. So I would do this in pencil in case you have to erase. I'm going to go kind of in here. And I would also recommend maybe you use a straight edge as well. Okay, so now let me see how I did. I'm going to count to see how many I have above the line. 1, 2, 3, 4, 5, 6 above. 1, 2, 3, 4, 5 below, and a bunch on. I think that's a pretty good split of the data because there's a lot of points that are right on the line. Okay, so just make sure you're splitting and counting and trying to include as many points as you can. All right, and then the next part I think isn't too bad. You're going to use an equation to make some predictions. Okay, so a computer program found that a prediction line is this equation right here, is a good fit for the data, where the W represents the weight of the diamond in carats and the P is the total price. So we're going to use the equation to predict the cost of 1 carat diamond. So that's the weight. So where the W is, I'm going to just input a 1 right there. Okay, it also says to show your work. So to do that, we're going to write down the equation. P equals 5,520. And then in place of the W, I'm going to substitute in the 1 carat because that's the weight. And then I'm going to subtract 1,091. So you would just show that. Okay, so 5,520 times 1 remains 5,520. And then I subtract 1,091 from that. Okay, so if I do that math, I'm going to get 4,429. Okay, so the predicted price of a 1 carat diamond is just over $4,000. Question C, we're going to use the same equation and find out how much more would a 1.75 carat diamond cost than a 1.25 carat diamond. And we have to show our work for this. Okay, so let's show our work. I'm going to write my equation. And now in place of weight, I'm going to do the bigger carat first. So I'm going to substitute in 1.75 for the weight and then subtract 1,091 from that. Okay, so grab your calculator and you're going to multiply first, multiply those values, and then subtract 1,091 from that. And that's going to give me 8,569. Okay, so the 1.75 diamond is very expensive, $8,569. Okay, so next I'm going to do the 1.25 carat diamond. So I'm going to put that one over here. So P equals 5520. And now I'm substituting in for the W, the 1.25, and then I'm going to subtract 1,091. Okay, when I do that, okay, so I'm going to multiply first 5,520 times 1.25 and then subtract 1,091 from that. And that gives me 5,809 for the 1.25 diamond. Now the question says, how much more does that bigger diamond cost compared to the little diamond? So these two numbers here, I have to subtract them because I want to know how much more the bigger diamond is. Okay, so my final step would be to subtract those values to find out how much more that bigger diamond would be. And when I subtract those values, I get 2,760. So my final answer, and then I would kind of, it's saying show your work, so I want to explain my answer. So I might write a statement there. I'll say the 1.75 carat diamond, because I got to answer the question, cost $2,760 more than the 1.25 carat diamond. Okay, so you want all that, and then I was thinking, just curious where these would show up on our original graph. So a 1.75 diamond would be kind of right up here. So the predicted price, it was pretty close to almost $9,000. And then a 1.25 carat would be like here on the predicted line. And that is just over $5,000. So you can use your graph to kind of get an estimate too, and your line of best fit. But using the equations really accurate and kind of easy to do. Just substitute in, multiply, and subtract.